Today I want to show you Epsilon-Delta definition. The definition is fairly simple to write, but a bit hard to understand. For every epsilon greater than 0, there exists delta greater than 0 such that 0 is smaller than magnitude of x minus c, smaller than delta, then absolute value of fx minus l smaller than epsilon. And here you will ask me what is c, what is l, and so let's write this. Now limit as x approaches c fx equals l. So the c here is this, and the l here is this, and this is this. Now if you see this, you may think this looks very complicated. How can I understand? I know, but you will understand. You need to feel it. This is the way to understand this statement. And for this, I want to draw you a graph. I'm not good about drawing graph, but I will try my best. This is graph. And assume this is very bad. Okay. I want to draw x square like this anyway. This is not good, but acceptable. X square. Now here let's select this color. Okay, here we want to find here. Okay, this is 2, this is 4. I know this graph is not realistic, but okay. And now this is like think like this, a circle. Now what limit does? In limit we don't say let's put the values and then let's say let's put the values and get the exact value. In limit we are thinking in this way. We are approaching to the number and we see is this continuous, and then if the function is continuous when we are traveling to the number from left hand side, right hand side and so on, then we say that this limit is excess at this point. So and then like when we approaching we get something like this, maybe this I don't really know, but we say this 4. I mean, what can we do with this value? So it depends on you. Anyway, let's erase this to have a space to explain you. Now this limit delta definition says us how close we want to be to the point. Like if we close to the point like 0,001, then it will be much more sufficient to understand, to say that the limit exists at this point. So this error percent will be lower. But now let's show you on graph. We can say here 2, okay, 2 minus delta. Wait, like this. Why I draw this graph this bad? I don't know. Like here 2 plus delta, and this is here. This is 4 plus epsilon, and here is 4 minus epsilon. And look, to do this square. So now we are analyzing this square. So we say that let's take a look to do this square, what happens inside of this, and then we can say the function is continuous, the limit is continuous, the limit is exists inside of this square. So this is how we are going to use epsilon delta definition. As if you make the square smaller, then the error percentage will be lower. Okay, so this is why I mean think like this. If you make this like this, we analyze this area. Okay, analyze this area instead of like this bigger. So we made it smaller to decrease error percentage. Now I think you understand. Now, I want to prove you that this also this is let's write this here. This is limit as x goes to 2, x squared equals 4. So the whole graph is this that you wrote here. Sorry, I forgot to write in the beginning. Now let's prove this true by mathematical statements. Okay, let's prove this. Now we know this is L, this is fx, and this is c. Now let's say x minus 2 is smaller than delta, because we know according to the statement. Okay, now I want to make this smaller than 1. Let's assume this distance between 2 and 2 plus delta and 2 minus delta is 1. Assume this is just 1. I don't want it to be very big, because as small, if you make it small, then the error percentage will be lower. So like if I give x 5, I mean if I try to like approach from here 5, approach from maybe let's say 50, because like this makes no sense. Okay, this makes no sense. The error percentage will be a lot of higher. So now, if, as I said, I only want the percent maximum 1. Like I want the distance to be 1. So we can write this. Absolute value of x minus 2 smaller than 1. And we say that here delta equals 1. Okay. Now here I will write this. When I saw this inequality, this is 1 smaller than x, smaller than 3. And now let's take a look to this. Let's take a look fx minus L smaller than epsilon. Okay, which is this x squared minus 4 equals x minus 2 times x plus 2. Now what we know is this here is smaller than delta, and this here is smaller than, I mean, let's find. So if 2 is 3 smaller than x plus 2 smaller than 5. Okay, this is smaller than 5, and this whole thing is smaller than delta times 5. Okay, and now we know this is also smaller than epsilon. So just like this, which equals to delta times 5 smaller than epsilon. And when we solve for the delta, we get delta is smaller than epsilon divided by 5. But now let's take a look to the graph again. If we chose delta to be here, then this statement maybe is not true. We only look at this box right now. We only look at this box. Okay, so if you want to be look what happened if you increase delta, you can put something different value to the delta, or you can just solve the inequality in different ways. You can approach to this problem in different ways, so you can get like better approximations. Now here we prove. Okay, this is now what we have done. Now what this means is, okay, so we actually finished. Now what this means is, for any given epsilon greater than 0, there exists a delta greater than 0. Sorry, I cannot write delta, but I don't know why. Greater than 0, such that whenever 0 smaller than absolute value of x minus 2 smaller than delta. We have, this is like f, we have absolute value of x squared minus 4 smaller than epsilon. Now, this approach covers all positive values of delta. But as I mentioned you, if you can play with delta, you can change the value, like you can make the error percent lower, higher. So you need to solve more examples. When you solve examples, when you approach to the problem in a different way, you understand the concept better. But now for this video, I hope you understand everything.